Hello everyone, this is my fourth session for multi-threading. In last session, we talked about little bit, callable, like what callable interface is, how it is different from runnable, and we talked about concurrent framework, right? So benefit of concurrent framework is no need to create a thread manually. Are you with me? How things happens? You have to create a thread pool, right? By using one method, factory method. People come with me. Today, I'm going to show you one example. Do you know what this line does? This line is used to create a thread pool. Noor, are you with me? You see? Noor?
Yes, Nagan. Yeah. Yes, I'm here.
Here what we are
I
doing,
can see that.
we are creating a thread pool of 3 threads, right? So 3 thread will be created. Which thread will do what? Answer is no, you don't know. Please come with me and reply.
Okay.
Mhm. So here 3 thread is created, right? Thread I'm going to represent with this color. This is the thread. This is the one thread and second thread. 3 threads are ready, right? So if you want your task should be execute on particular thread, what you need to do? Noor, yesterday we did it. Remember, you have to use this interface dot submit method. Remember, forget it. In this submit method,
Yes, I
what you need
remember.
to do? You have to pass your runnable or callable task.
Task.
It could be anything, right? Difference between runnable and callable task is runnable task does not return any value and it cannot throw any checked exception. But callable can return a generic value and it can handle checked exception also. You can throw checked exception in callable task. So when you submit your task, right, like this, it would go to the thread pool queue, right? Every thread pool
Thread
has a
pool.
queue. When you submit any task, first of all, it will go to queue,
Thread pool.
and this
Queue.
queue, yeah, thread pool queue, and from here your thread pool can pick any task and it will execute it, right? So here your number of tasks is less than number of thread, but in real life, number of tasks might be greater than number
More
of
than.
available thread in the pool. So this is your thread pool, right? There is a lot of factory method thread pool. There is a couple of many factory method through which you can create a thread pool. New fixed thread pool. Noor, it will create only 3 threads, right? Not more than that. So when you
Yes.
submit your task, do you know which
Thank you.
task will be assigned to you, which thread? Answer is no. You don't know about it. It is
Mhm.
internal. It's internal, right?
Yes.
Internally, it will assign any task to any thread. And one thread can perform, execute multiple tasks, but at a time only one, right? Yep, that's clear. That we know.
Okay.
This diagram is clear or you got confused?
That's
But
clear.
here benefit is you should not bother about how threads are created, how you can assign a particular task to which thread. And one thread can perform multiple,
Multiple
it can
tasks.
execute multiple tasks one by one.
Mhm.
Exactly. So here I'm going to create a thread. In this, I would like to show you future. There is an interface future. Using future, you can track your task, right? Using future, what you can track? You can track what is the status of particular task.
What is future
Using
by
future,
itself?
future is the interface in multi-threading.
Interface.
So let me show you. Yeah, yeah. I'll show the example of it. That is in my agenda. So if you allow to me, I can create a task, right? Future demo we have. Let's see. Let's understand it, my dear. Can you see this? Please, if you don't understand, let me know. Here, your question is what is the future? I said future is an interface which represent asynchronous computation. of the task. End of the day, it will return some, it will hold the value written by the callable task. But I'm telling you, using this, you can hold the status of running task. You can cancel it as well, right? And you will also come to know whether it is completed or not. Let me try. Guys, focus on this. If you understand, sorry, not this, future one. Hey guys, you tell me, you understand the definition of this class?
Mhm.
Hello? What future class is supposed to do? This task, right?
Okay.
This
Yep.
task. This is callable task. Tell me, once this task is completed, it would say call is executing. Hey, I have done with this. So what it is going to return? Any guess? End of the day, after completion of the task, what it is going to return, dear?
String.
I have
String,
done with
hey,
this.
I have done with this.
Yeah. So here, you understand this line? This line is doing what? This is creating
A
pool
thread
of,
pool.
yeah, pool of threads. Right. How many threads, man? 3 threads.
3.
Three.
Yeah, not more than that. So here, what I'm doing, can you see this? Service. I'm submitting my callable task. And this callable task, I'm going to track with which interface? Future. And this will hold the, hello? This will hold the result which will come after completion of the task. So future is basically representing asynchronous computation of task. Ram, this is, you understand? This future interface is pointing to,
Future call.
if you don't understand, I can give you, I can show you in the diagram, right? Like when you submit your task, right? Then whatever task you are submitting, right? It is going to be pointed by the result. So how you can get the result? Here we have a method, blocked method, result.get. You are saying I want result from this task. What is the meaning of one? You can wait up to 1 minute, right? If in 1 minute result comes, you can wait, otherwise you will not wait. Ram, if you
Yes.
don't write that means how much you want to wait for the result?
For
Infinite,
me,
right?
infinite.
But here you
Mhm.
want to wait for particular this. I hope you understand. What will the output over here, man? Output will come, hey, I have done with this. Can I try? Yeah. People reply. Chu, you got it? You got the flow of it or not?
Yes, I do.
What about other people?
So it
Ram and all. You got the
returns.
flow of it?
So it return. So it returns future when you submit a callable for it, right, to execute concurrently, right?
It will return this is a result. Let me show you one more nice example of future. Please, I'm going to type whole program in front of you. Please let me know if you don't understand, okay? I don't want to waste my time. Here, I want to make a task called class mathematics. Please let me know mathematics. And it is going to extends implements. Please help me. Callable.
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 And it is going to return some random value.
Integer.
It is up to
Integer
you.
or
Yeah,
string.
integer.
Okay.
It is up to
Long.
you, right? And here
Boolean.
you
Boolean.
can implement it. So what do you want to return? You somebody saying here, can you write the constructor? Public this. And whatever value you are passing to the constructor, you want to return that. True. This is clear? Private.
Mm-hmm.
Here, integer. You know this. This dot first rule.
Now.
Here, what you want to return? You want to return the same number. That's it. Once this task is completed, you want to return this number. If you want, you can multiply by 10. That's fine. It's okay, man. This task is going to return what?
Number.
It's going to
Number.
return num
Whatever
times
number
10.
you set. Yeah. So here I'm going to write main method. Let's create a thread pool. In order to create it, you can use executors. Executors is
Service.
the utility class. And
Service.
here we have many methods, man. New, you can create a new cache thread pool. In this, there is no limitation of the thread as you need, like, in new cache thread pool, whatever thread you need on demand, it will create it, right? In this, we do not have limit. It will create thread on demand. If you need 10 threads, it will create 10 threads. If you need 5 threads, it will create 5 threads. So it is up to you, but you have limitation. You cannot create more than this thread. It is up to you, right? So I want to create how many threads, man? 5. And this thread pool, how you can refer? Any guess? Executors, please reply.
Executor
Execute
space
service.
ex. Okay.
Yeah. Then after it, how many tasks you want to submit? Can I use a loop? Ram, I want
Yes.
to submit 10 tasks. It's okay?
Is less than 10?
Yeah, yeah. 1 up to 10. Dot submit. And you can pass this mathematics, Mr. And in this constructor, I am passing X, right? So first task will take 1 second. Let's make it only for 5, right? So, oh man, first task is taking 1, right? Second one is taking 2, 3, 4, right? So you know what this is going to return different value? 10, Ram, 20, 30, 40, and 50. That's fine. Yeah. Hello.
Mhm.
And it will return future of integer, man.
Integer result.
Yeah, result. So it will point one by one, right? But you have to track all the result, right? So what you can do is you can create a list. Otherwise, you will lose the result. Okay. So I'm just creating a list. Shoo. I'm just creating a
And then
list.
you will add the future result into the
Exactly. Yeah,
future
yeah, yeah.
list. Okay.
Actually, when you submit it, it will return a result for every submitted task. So in order
Mm-hmm.
to track it, I'm going to add one by one in the list. So this list
Yeah.
have all the one future integer is pointing to one task. So it will hold how many future object here?
Fine.
How many objects? Answer is 5. Now what you can do, Chu? You can use a loop, right? And in this loop, you can iterate one item at a time, right? One item
Yep.
at a time from the list, and you can point to the list, right? So here you can use integer sum equals to 0. So what you want, whatever result is there, you want to do cumulative addition. So item dot get method is there, right? Already we talked about Chu. So it will go to
Mm-hmm.
the every result in the list written by every task, right? And eventually all the value you will get it. Got the idea? Yeah. Here you have you can take the 3 thread, right? So benefit is all the 5 tasks will be submitted to the pool, and 3 tasks will be executed parallel. Once thread computes its execution, it can pick other tasks. This program is clear or not? Let me run it. What I'm going to get 10.20, you can add it, right? 90, 100,
Yep.
and 150. That's fine. I don't know how many people understand this program. Ram, what about you?
Yes, sir.
The here important is when you submit your task, this task is pointed by result, and this result I am holding into the list. In that way, I am able to hold all the result which is coming from submitted task in the list. So one future object will represent result of one task submitted to this pool. That's it. Hello.
Again, can you explain line number 36? I'm lost there.
36. See,
Yes.
in the list, we have multiple
Mhm.
future, and every future is holding result from task. So I'm accessing one record at a time, right? One item from the list. And I'm saying, hey, item future, give me the result, right? Dot get. Dot get means you want to get the result which you hold in the future. That's it. So we have 5 future.
Oh,
From
okay,
every
okay.
future, you are getting the result of integer type. That's it. And storing. True. Got it?
Mhm. Yeah, I got it. That cleared my mind now.
In this, see, again, I'm creating the pool, but here I'm using schedule executor service. Oh, nice. You need to understand what is the meaning of it. True. In previous program and this program, no difference, man. Only I change here what? Earlier I was using executor service. Now I'm using scheduled executor service.
Okay.
What is the benefit of
So
it?
they still create the thread pool.
Yeah, three
This-
threads
okay.
are there, but in this beauty is I'm using a method scheduled add fixed thread. In that I am passing this task, right? So what my intention is, whatever this task here, this task will be always runnable. Are you with me? You cannot pass in this. I'm sorry. You can in this method you can pass scheduled add fixed rate. In this method you can pass only runnable. Can you see this? Chew.
Yep.
What is the benefit of it? Let me tell you. Your intention is this task, whatever you are submitting, it should execute again and again after every 5 seconds. You got it or you got confused? Let's make every 3 seconds. Chew. This
Okay.
task is going to execute every 3 seconds. And what is it? 2? It is initial delay. When you submit your task for 2 seconds, it would be not do anything, right? After 2
Yep.
seconds, it will going to execute. Then every 3 seconds, it will repeat.
Okay.
Hey, man, this is good. When you want to execute same thing again and again, again and again, again and again, right? Waiting for
Yes.
2 seconds. You confused or you got it?
No, I got it, but isn't callable like we have more benefit using callable?
Here, actually,
Because
when you schedule something, right, you are not interested in its output, right? Whatever value
okay.
is going to return does not make sense. That's why you don't have any return value over here. You see, it's really magic. It's
So
really magic.
the beneficial for us using this schedule is that it'll repeat itself and it will have a
Exactly.
limit
Let
for
me tell
us.
you want to, sometime you have to write some job, polling. You want to poll some data every 1 hour, right? Then it is nice. Polling.
Oh, okay.
Basically, you want to schedule a task at fixed rate, right? So you have another method, right, where you can execute some task, not again and again. You want to execute only once, right? Then return value makes sense. You want there should be tasks which should execute only once at night 10. You can do it. Are you following me? For that, we have another method in this. I can show you that also. What method? Sorry. I don't know. You're following me or not? Yes, dear friends. True. Another method we have in this, let me tell you. Dot schedule. Can you see this? Oh man, in schedule, you are not replying. Schedule means here you can use runnable and callable. Chu, are you there? Guys, I'm not audible.
Yes, you are
Yes,
audible,
you
sir.
are. Where people are sleeping. Here, I want to make a callable. Why, man? My requirement is I want this happy 100 task
Return something.
return something because I want to execute only once at particular time. So here you can use this, and here you can return some what, man? Random value. It is up to you. New random. Dot next. Hey, are you with me or you got confused? Ram,
Yes, sir.
here I want to use. I want to schedule the job. When you want to execute, you
New
want to
happy
execute
100.
it initially, right? you want after 10 seconds,
10
right?
seconds. Mm-hmm.
So here you have to write.
Oh, sorry, I got disconnected again. My
No
connection
problem.
disconnected.
I understand. Here, what is the difference between schedule and schedule at fixed rate? It is going to repeat again and again, right? But it is not going to repeat. Schedule can take any parameter. It can take callable task as well as runnable task, and it is going to return schedule future. Return value, right?
Mm-hmm.
It is going to hold your. Not here. I'm sorry. Actually, I'm in wrong window. I should come over here, right? People.
Yes.
It is going to return schedule future. Are you following me?
So it
Result.
is most of the time this logic used in the calendar.
Yeah. Actually, you are going to execute after 10 seconds from now,
Mm-hmm.
and result you can print it. Okay. So this result we are holding in scheduled future. Scheduled future is similar to future, right? Here we are dealing with scheduling. That's why we can use scheduled future. Don't take much tension. Dot method is there. Get. Hello, I can run it. Allow me. After 10 seconds, it will print the result. Ram, after 10 seconds, value will come, random value, right? Which you don't know. Can you see this?
Yes.
Hello? Just willing to know. Do you understand the schedule and fixed scheduled at fixed rate? Yep.
Mm-hmm.
Yep. Done. I think this is enough for concurrent framework. We have a lot of stuff in this, right? But you understand? I talked about executor, then I talked about executor service. Are you following me? In
Yes.
executor service, I just wrote a program where we were dealing with multiple tasks, right? And I don't know, you got this much people. Then we talked about scheduled executor service. In that we have two methods: scheduled at fixed rate and schedule method. Schedule at fixed rate only will take callable task. Why? Sorry, runnable task. Why? Because it is going to execute again and again, right? But here it is going to execute only once after this much time. So return value makes sense. It can take schedule can take callable and runnable. I have done with this session. Okay. So
Okay.
next and last, which I'm going to teach you for today is, if anybody have any question query, I can answer it before jumping to the next topic. The next topic which
Concurrency.
I'm going to teach you is volatile. And I'm telling you, volatile you can read on the internet and you'll be always get confused. Okay. So let's understand the concept of volatile, which is very popular in the multi-threading.
Vola and tile. Volatile.
Volatile.
Mm-hmm.
So you need to understand when you execute a task in a thread, how it is going to be executed. So, in your real life, in computer, right? In computer, we have CPU. Do you know this fact? CPU. So normally, nowadays, multiple CPU is coming. Single CPU or multiple CPU? Any guess? Multiple CPU, right?
Yes.
Core 2, Core 3, you know it. And every CPU has its own internal memory. I don't know you know it or not. That is called cache. L1 cache, L2 cache, L3 cache. Have you heard about it?
Yes.
Do people know about computer or not?
Yes.
Yes.
I
Yes. We
know
heard
about
that.
computer, but what is caching here? I don't know. Zero knowledge of caching.
I
You
don't
are
know
not from
what's
the
that.
computer science background, 100%.
Yes.
Because people who is from the computer background, they must be knowing about the cache memory.
Yes.
That's
I'm
fine.
not a
See,
computer science background.
I know, that's why. No worries. Here we have CPU.
I'm
Every
physics
CPU has its
student.
cache memory. Which memory, man? Cache. Are you with me?
Mm-hmm.
And this cache is a memory, and this cache is made from the register. I'm not going to in that much detail. And register is made from flip-flop. I'm not talking about that internal, okay? And then there is a RAM.
You can't store the data.
Yeah. Anybody heard about RAM? Random
Yes,
access memory?
Yes.
yeah, random access
Yes.
8
memory.
GB RAM, 10 GB RAM, you know it.
16 GB.
So when you run your Java program, JVM is created, and JVM store data and everything, right? You have seen in last session there was a block diagram for Java virtual machine, right?
Yes.
And that JVM allocates memory in Java heap and method area, and everything is present in the RAM. So nice. Where your Java virtual machine runs?
RAM.
RAM.
Inside the RAM. You should know it. So this is RAM, okay? And random access memory. Oh, Ram, that's your name. Okay,
Yeah, I know.
good, good, good. You should be very happy. So when you run your thread is going to execute. Hey man, you are running a thread, right? So let me show you. Suppose we have two thread, right? And both threads are running. Are you following me? So every thread stores some data, right? Actually, suppose your data is present in the RAM. It is x equals to 100. Say yes. I'll
Yes.
show you this example, right? This data is present in the RAM, right?
Mhm.
And if any thread wants to perform computation, because this thread is executing
At the same time.
in the CPU, right? So suppose this is running on this CPU, right?
Mhm.
RAM, every thread executes inside the CPU, or you can say on CPU. So here you need to understand this this thread is running on the CPU
Yes.
and this thread is running on the CPU. I'll show you the same example, right, in the code. So what it does, suppose this thread wants to, let me write some code for it, then you can understand better, okay? So thing is, we have two different thread, right? Thread 1 and thread 2. I'll show you the same example, RAM, thread 1 and thread 2. And both thread are reading the same X, right, from the RAM. They can read it or not? They can read it, right? Because whatever
Yes.
data is there, it is shared. Say yes.
Mhm.
This data
Yes.
is shared. Yes.
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 Why this is shared? Because it is in Java heap, right? And Java heap is present in JVM and JVM is present in RAM. This is shared. I'll show the example, okay? Shared. So what it will do, man? If this thread wants to perform some operation, for example, Ram, you have to help me, right? While foo, right?
Oh,
This method. So this thread wants to do what, man? You
perform
can
Nothing.
talk about the
operation.
run method. You can say again write run method. Okay. In this, it is going to
Override.
increment the value of it by 5, right?
Mhm.
And then maybe printing a whatever system dot out
Route.
dot colon
Mm.
x. So what happened? Every thread is going to perform this operation. Assume, right? First thread is incrementing the value of it by 5,
5.
and second one is incrementing the value of it by
5. 10.
like 10. So for optimization purpose, every thread, for what purpose? Optimization purpose, every thread uh, make a copy of this variable x in their cache memory. What I said?
Mhm.
They make the copy of it. Oh man, confused? No.
Mm.
They are going to make their own copy of it, man, before performing execution,
Mhm.
right? Yeah, 100. And this is also going to make it when they does, man, when they are going to do it.
So,
If
so
it is local, right? If they want to perform some computation, so first of all, they will copy this X data inside their
into
cache memory,
CPU. Cache memory, cache memory.
cache memory. So there is some problem. Let me tell you what problem will happen because of it, right? Problem is, let me make it right. Hey, what is the problem? Problem is, suppose I'm a first thread is updating the value of X, right? So he's going to this thread is going to update this value in their cache memory, right?
Mm-hmm.
So after updating it, it would become 105. But 105 immediately will not get updated into RAM. Yes or no?
Yes.
Yes.
You're not replying. Oh man, what happened? In this
Executing it
case,
will.
right, it is incrementing the value of it, but it is not reflecting in the
RAM.
shared memory. If any thread wants to read the value of it, they can read the wrong value or not.
Mm-hmm.
Oh man, there is another thread who is going to read the value. So tell me, he will read the updated value immediately, or he will read the wrong value? Tell me. This
It will
thread is
read
able
the
to
wrong value.
increment the value of it by 5. Actual value is 105, but this thread is reading old value. So do you understand the issue? This issue is coming because of what, Ram? This issue is coming because of
Multiple CPU.
multiple CPU and cache memory.
Cache.
Yes,
Cache
ma'am.
memory.
Again, I'm telling you. Normally, what happened? You answer should be Nagin. Could you please show me this example? I'll show you. But what happening, man? Actually, problem is when thread performs some operation on shared. Shared variable means this is shared by multiple thread. So tell me, what is the issue, man? All in this, two threads are updating the value of x. Ram, what I said. Two threads are updating the value of it, and third is reading it. So tell me, in this program, do you think this thread 3 will always read the updated value? Guaranteed? No,
No.
No.
it's not guaranteed. Clear? If you want, right, when some thread is performing some operation on shared variable, which is in the RAM, this value should not be cached because of the optimization purpose. How you can do it? You have to make this volatile. RAM. How you can solve this problem? By using
Make
keyword volatile. Then what is the benefit of it? Volatile means you are giving instruction to the every hello. You are giving instruction to the CPU. Hey CPU, when I will perform some operation or operation of it, you are not supposed to make the local copy of it. Every thread has to read the value from the RAM. RAM. What is the benefit of making this variable volatile? Tell me. If you make volatile,
It can be
it,
changed.
it
no
can
thread
be.
is going to cache the value in their cache memory. They will directly perform read and write operation from the RAM. So benefit is, if first thread is incrementing the value of this by 5, immediately this 105 will be in the main memory, and thread 3 can read the always right value. So who will tell me what is the benefit of volatile? Volatile means you are saying, hey CPU, don't cache the variable for optimization purpose. Direct read this value from where? RAM.
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 Don't do copy and paste.
Don't do copy. You directly go to the RAM, take this value and increment it and set it, so that other thread immediately can get the latest value. This is called visibility. So I can say volatile ensures visibility. Visibility means when you make some changes in the RAM in shared variable, it will be immediately visible to
Other thread.
other thread. Yeah, you got it or not?
Got it.
So the change will be in RAM, not in cache memory, right?
Exactly. It is not going to be cache. But your question should be, could you please show me some example? Right?
Yes, of course.
And
Yes.
one more thing I'm telling you, there is a concept in Java memory model that is called happens before relationship. And I'm telling you, this you can read again and again, and you won't understand yourself. What happens before relationship? We'll talk on that as well. Again, I'm telling you, if you are going to read this thing yourself, I'm telling you, it will take a lot of time to understand yourself. Happens before relationship. I'll tell you what is the meaning of it. Okay, this is related with volatile, right? Actually, there is a concept of JMM, Java Memory Model, which was introduced in Java 5. Java Memory Model. I'll tell you, as per JMM, Java Memory Model, what is the happens before relationship. Okay. Okay, please. Is clear?
Okay,
Yeah.
see some
Let me show.
example.
This concept is clear, Chu, volatile.
Yes,
If you
I
make any
understand
shared
that.
variable volatile during the competition inside the thread, it is not going to be cache. If you want, I can write it, right?
Yes, sir.
Volatile shared variable will be never. What is it? Volatile shared variable will be never cached. Cached inside
CPU.
CPU. Volatile shared variable will be never cached inside CPU. It means any thread can read, write data directly inside main memory. RAM is also known as main memory. Got it? Volatile shared variable will be never cached inside CPU. It means any thread can read and write data directly inside the main memory. It means other thread will always read
The
updated
latest. Oh, yeah.
latest. Right, you are right. Latest data from the main memory. I hope this much is clear to everybody.
Mhm.
It's clear.
And let me show the example of it. For volatile, already I have some example of it. Let me show you very quickly. Simple. My dear friends, you have to tell me if you understand. I'm not making it okay. So you have to understand this program, otherwise I can make it simple. What this program is? Here we have a shared variable flag, right? And this flag is shared by this thread and this. We have two thread. How I'm making thread? New thread. You know this concept? This is called anonymous class, man. I'm creating a thread and passing the task. If you think it's complex, right? I can make this program as a task. Or if you understand, I can go ahead. Ram, let me know what I'm doing.
Me,
On the fly, I'm making the thread, I am passing the task and starting the thread. So this thread, when you start it, it is going to execute this task. This code is written so in such a way so that you can use the same variable among both the thread. This, how many people are able to understand this program? Please let me know. Otherwise, I can make it simple.
yeah, I understand that one.
Here, what you are
But
doing
I don't
on
know
the fly,
about the people.
you are making an object, right? On the fly.
Yep.
Let me make it little bit. What is the purpose of doing it? Because I want to use this global variable, right?
Mm-hmm.
So new thread, I am making a thread, right? And
Yes.
passing a runnable task. Yes, you know? Exactly.
Yep.
This is called anonymous class. If you see my lecture, Java 8 recording, day 1 or day 2. I think in day 1, we have this concept, anonymous class, right? This you can write as a lambda also. New runnable. When you start this thread, what it is going to do? It is
It's going to create it.
going to, yeah, it is going to print the value up to 1 to 5,000. Are you following me? After that,
Yep.
you are just this thread is sleeping for 100 seconds. Then you are making this flag true. So tell me, the moment this code will execute, at the same time, this thread, can you see this? This is example of lambda. Oh man,
Yep.
new thread, and I'm passing this task. And when you start this new thread, this task will execute. So what this task is going to do, flag is false in the beginning. Yes or no?
Mm-hmm. It's
Reply.
false.
It is false in the beginning, right? So if it is false, it will go in the infinite loop or not? Tell me. As long as this value is false, it will go in the infinite loop or not? That's my question to you, Chu.
Because
The
it's
question
a
is,
I plus, then
as
I'm
long
sure it
as,
will go.
yeah, as long as flag is false, right? Then this loop will execute and it will be I plus plus. So as long as it is false, it will always going to be execute. Remember? So what happened?
Yep.
Like here, value of a flag is false.
False.
So both the thread will read this value and they will make their own copy of it in respective CPU cache. Say yes.
Yes. So it'll run the new
Let me
thread
tell
down
you.
there
Let me
and
tell you.
up there.
Actually, I'm going to make a diagram for it. Guys, this program, if you understand, volatile is clear. This is the global variable you see, right? It is going to be shared
Yep.
by this thread. So I'm telling you, both the thread are going to execute at the same time. This is the first thread, okay? And this is the second thread. So what I'm saying, when you run your program, right? So they are going to read the value of their flag because this is shared and this is allocated inside the
RAM.
chew. It is inside the RAM, right?
Yep.
So it is inside the RAM. Let me make it a little bit compact. And this value is not this. This value is false. So this flag, whatever I'm showing, it is inside RAM. So what happened? This is not volatile. So because of it, what happened, man? Flag false. Hello. This value is here. So tell me, as per discussion, every thread will make its own copy or not?
Yes,
Yeah.
because it's not volatile.
Yeah, it is going to run the CPU. First of all, it will copy this value flag equals to false in their cache memory. Say yes.
Yes.
And
Yes.
they are going to operate on it, right? So this will do what? It is going to, as per this, right? It's just making a copy of it and it is going to execute how many times? 1 to 5,000. What confused or you got it? They are going to cache this value. Similarly, this thread will also make a copy of it. Say yes. And it is going to make a
Yes.
copy of what, man? Flag. In that case, value is
False.
flag. This value is flag equals to false in their register, in their cache
Mm-hmm.
memory. So you see what happened. As long as it is false, right? It is going to be in infinite loop or not?
Yes.
Yes.
Infinite loop. So thing is, if you see here, it is going to execute 5,000. After that, it is sleeping for 10 seconds, 100 seconds, and then it's making its value flag true. Are you following me? So it is
Mhm.
going to make this value true, first of all, in cache, right? And this cache is going to update your main memory, right? But problem is, you may be updating it later, right? But this thread is using their local copy. It is not going to read the value from the main memory. Do you understand the problem?
Mhm.
True. What happened? Initially value is
Oh,
false, right? So this thread got the false value and is stored in their own CPU cache, right? So
Mm-hmm.
even though second thread is changing the variable flag true, it's changing in the local, local cache, and eventually it is getting updated into RAM late,
RAM.
right? But whatever updated value is there, it is not going to be read by this thread because this thread is reading the value from local cache. Are you with me? Not from the RAM. So do you understand the issue
Yep.
in multi-threading? This problem will always come in multi-threading, right? Because in multi-threading, when your thread executes on the CPU, it make the copy of the variable on which it wants to perform computation in its cache memory. So do you understand the issue, man? If I run this program, what happens? Chew. If you run this
You
program,
go Ethernet.
yeah, it is going to, it will go in the infinite loop. Let me run it and
Stack
show you.
Overflow.
Yeah, I'm going to show you. It's not a Stack Overflow, man, because here you are not calling same method again and again. Okay, it's not like that. So let me run it. If I run it, what happened, man?
You go
Here you can
infinite.
write the message, shout, hang up. Okay, chew. You got the reason? even though flag is becomes true, right? Once flag becomes true, this condition should be false and this should be print, right? But why it is
Yeah.
not printing? Because you see, I'm just running it. Can you see this? Hang up. Hang up means it's here, it's hang up. Are you with me? It's not showing job done, right? What output I'm expecting over here? Job done. But it's not coming. You know why? First thread is printing the value from 1 to 5,000. Then second thread hang up, right? This value is not going to be changed from false to true. Why, man? Hello? First thread is
Because
man. The first thread is updating the value. Let me write it. Here, if you read the value, right? What is the value? Flag.
true.
Yeah. Flag becomes equals to flag. You got this concept or totally got confused? Please let me know. You got confused? No. If you run it, right? Flag becomes
True.
Why is not coming hang up? Give me a second. Let me
You
open it
said,
again. No,
you
no,
said,
wait.
Mhm.
Give me a second. I'm just printing the value over there. Okay. This. Give me a second. And I'm reading it. What? Suppose I'm not reading it. No. I'm sorry. No. I have to wait, right? I'm waiting for 100 seconds, right? Cool. Flag becomes true. Let me see how many threads are running. Oh. It's multiple copies running. You understand? Let me run it. Like ideally, this message should come. Can you see this? Hello? Man, you guys are not replying. What I said. See, this value becomes true, right? Even though it's become true, but it hangups. This value, why this value, it not going to read true? Reason? Because it is always using local copy of it. True.
Yep.
Do you understand the
So
problem?
we want to get a copy from the RAM.
Yeah. Actually, it is taking, initially a thread wants to perform some operation. It take the value from the RAM and make a local copy in the cache. After that, it is always using the local copy from the cache. That is the problem. How you can fix it? In multi-threading, if it is a common and shared, you can use here which keyword?
Volatile.
Volatile. And if you use volatile, you are giving instruction to the CPU. Hey CPU, when as a thread I'm going to use this value, don't make local copy of it. Always read and write from the RAM, main memory. So what happened in this case? When first thread will make this value flag true in main memory in RAM, then while loop is again and again checking it, right? So it will also read the value from the RAM, right? So this program will terminate or not? Of course, man. It would say job done. And whatever value of I that time is there, it will print the same value. Can you try?
Yes.
True. I'm trying now. Problem is solved. I hope you understand the issue and you have seen also how problem is solved. Can you see this? Job is done.
Okay,
That
I think you clear my confusion now.
Mm.
Can I explain? Is it because for the new thread, right? For line 27 down, it make a copy that is false. That's why it's not printing job done. But since we changed it to volatile, then the first one will update to true, and then it'll go to line
exactly.
31.
See, both are running
Yeah,
parallel. This thread and this thread are running parallel, right? Don't think it
yep.
is sequential execution. So as long as
Mm-hmm.
this value is false, it is in infinite loop, right? I plus plus, I plus plus, right? The moment you are
Yes.
making it true, then this
True.
condition
Yep.
become false. And
Yep. And then
it's
that's why
saying job
it'll
done.
print.
That's it.
Yeah.
That's why I make
Yeah, it's
volatile
clear now.
here. Volatile means this value will be
Temporary
never cached for particular thread in the CPU. It will be always read and write from the main memory
main memory.
from RAM. I hope this is one
Okay,
of the
it's clear
nice
now.
example of volatile.
Mm.
Clear? So I have
Yes.
many program for volatile. I have other program also, right? This is the not only program. We have other program also. I'll share with you. Okay, you can have a look on it. Can you see this? This is also one of the nice example. Like here we have multiple thread, and all thread are incrementing the value of this counter two. If you don't write volatile, right, it will show you unexpected result, because when you want to increment the value of the count, every thread will make a local copy of it and they will increment it. You understand the issue?
Mm-hmm.
So if multiple
Yep.
thread are going to increment the value, right? So if it is not volatile, they will make their own copy and increment it. They will be in trouble, right? When you are printing
Yeah.
it. So you can try this
They'll use the
program with,
local value.
yeah. Because why problem is coming? Problem will come when we have multiple thread and they are going to work on shared variable. If it is not volatile, it will not work perfectly fine, because if you don't have volatile, it is going to make a copy of it in a local cache, right? In CPU cache. Clear? Done.
Mm-hmm.
I don't know you got this much or not. So what we have done today, we talked about, concurrent framework. And in this, we talked about thread pool, right? We started with fixed thread pool. Then I have shown you the example of scheduled thread pool,
In
where you can
future.
schedule your task, repetitive task, and you can schedule your task for one execution also. And today we have learned future and scheduled future. And in last, we talked about volatile, right? In this, only one topic is left, that is called happens before
Happy New
relationship. Happens before relationship. This is a very interesting topic. I'm just giving this opportunity to you. You go and read this yourself and get confused. Come in next session and discuss with me. Guys, I hope this much is enough for today. So I have done for today. Thank you so much for your time. See you in next session on Monday. Bye.
Thank
Have
you,
a good
Nagi.
day.